This is the tutorial for Chapter 4, Section 6, titled Writing Equations in Slope-Intercept Form. So let's take a look at the types of problems we're going to end up seeing. First of all, we need to know what the slope-intercept form is. So we've graphed items, or graphed lines in this slope-intercept form, and it goes this way: y equals mx plus b. Y is our output, x is our input, b is the y-intercept. It's where the line ends up crossing that y-axis. So that's an important part, and m, again, stands for the slope. So remember, the slope is a fraction. It's a change of y over the change of x. Remember this delta symbol, this triangle, it means change. So change in y values over the change of x values. And when we do that, we can do one of two things when we've got the line. We can either follow what it says, like start from the point that we're at, and go down to the elevation, in this case, to this other point, and then go across to find out what that change of y values and change of x values are. And that's the way we're going to end up doing it here. You can see how they're showing us going down 3 spaces, and that's what we're doing. You always look at the intervals they're going by. Here they're going by 1, so you can't just always count the spaces. You need to look at the intervals that they use. So 1, 2, 3, they went down, and then they went to the right 1, 2 spaces. So I see that the slope of this line is -3 to 2. The y-intercept, well, that's where it crosses the y-axis. It shows it right here, 0, 5, and so that's 5. So if I wanted to write it in the slope-intercept form, which goes y equals mx plus b, I just have to substitute those values of the slope and the y-intercept into the equation. So y equals -3/2 x plus 5. That is the equation for this line. We'll take a look at the one down below, and we have a similar situation where we've got these arrows showing how many spaces, and I definitely see that we're going by 1, so I count the spaces: 1, 2, 3, 4, 5 spaces up. So the slope is up 5 spaces, and it is to the right 1, 2, 3. So this is a positive slope compared to the last one, which was heading downhill from left to right, making a negative. Now I see that the y-intercept is this time on the underneath the x-axis, so it's negative, so it's a -3. That's where it ends up crossing that y-axis. So when I rewrite the equation, again, I'm just putting it into that slope-intercept formula, and I'm left with y equals 5/3 x minus 3 this time. So looking at this next one, again, I see that the intervals are just going by 1, so I can count the spaces: 1, 2 spaces up, and 1 space to the right. And that's what I did here, up 2 over 1. Now there is another way to come up with that value. If I wasn't given the graph, you could always take the points that you have and use this formula. It goes this way. The slope is the change of y, so y minus y1 over x minus x1. So I can take the two y values, the 4 and the 2, and I can subtract those. So I took these two numbers, the 4 and the 2 here, and then I'm subtracting the x values. Now I got to be careful though. I got to start, since I started with this 1, 4, I got to start with that point's x value. So it's going to be 1 minus 0. And so if I do that work, you see you get the same exact slope, 2 to 1. So I see my slope is 2 to 1. My y-intercept is where it crosses the y-axis at +2. So I just substitute into that slope-intercept formula, which goes this way: y equals mx plus b. So I'll write down y equals, and then my slope was 2. So I've got y equals 2x plus 2. And if you wrote 2 over 1, that's the same thing as saying y equals 2x plus 2. So sometimes it's nice to have the slope as a fraction to be able to graph points, but if we are trying to just write the equation, we like it in the simplest form, and without that denominator, since we always just know that the denominator of any whole number is 1, this is the simplest form. Taking a look at this next line, one thing I always look for is the direction of the line. I see this as a positive slope since it's going uphill from left to right. This one is a negative, so that way, since I know it's negative to start with, I don't have to worry about messing up on my signs. So I see I'm going down 1, 2, 3, 4 points. So my slope is down 4 points, and to the right 1, 2, 3. So -4 to 3. And you can get that doing the same thing we did with that formula. So if I start with that -1 minus -5 over 0 minus 3. Now if I do that, I add the opposite here, and I get positive 4 over negative 3. And either way you graph the line, it would still end up on that same line. So if you have a negative slope, you can either put the negative sign with the numerator, the denominator like I have here, or if you put it right in line with the fraction bar. So if we had the fraction bar right there, right in line with the fraction bar, they all mean the same thing. So it doesn't matter where the negative sign goes. Typically, let people see it up in the numerator or right in line with the fraction bar. So that's the way I'll end up doing it. The y-intercept, right where it crosses that y-axis at negative 1. So I'm just rewriting that the slope-intercept formula, and I substitute. So negative 4/3 x minus 1. That's the answer. So let's take a look at a word problem that we might end up seeing. It says that you organize a garage sale. You have $30 at the beginning of the sale. You earn an average of $20 per hour. Write an equation to represent the amount of money y you have after x hours. So it tells us what y is. Y equals the amount of money, and x equals hours. And so when we look at the problem, we've got two numbers. We've got a number that we begin with, and the key is this word right here, beginning. This is our starting point. And then the part over here, I see $20 per hour. That per hour tells us a rate. And you see how x is in hours right here? So in our y value is in dollars. Because our y value, remember our slope is always the change of y over change of x. So our value for the slope here is going to be dollars, because it's the change of y, over number of hours. So that is our slope. That is our rate. And that's what they're giving us right here, that $20 per hour. So the units kind of give it away which one our rate is. When you see the word per, typically that's your rate. But look at what they give you for y and x. And if those units match what the rate shows, dollars per hour, then that's your rate. Now, if we look back at the formula, it goes this way, y equals mx plus b. If we just looked at just the b value, that's the y-intercept. That's like our starting point. So this term right here, if I set x equal to 0, if I had 0 hours, that means that would cancel out this entire term. 0 times m would make 0, and I'd be just left with y equals b. So this is the beginning, and maybe that's why they use a b for the y-intercept, because it's the beginning value. It's the starting point. It's what you begin with. And so, starting point. And so, what that tells us is whenever we see a beginning value, it tells us the beginning, this is our b value. And this one right here, when we see that word per, look for the y value and the x value. See what they are, dollars per hour. That means this is our slope. So we are going to write it in this form, y equals mx plus b. I know what the slope is. It's the rate of change, $20 per hour, times by the input, the number of hours, plus what we began with, and that is 30. And so there it is, y equals 20x plus 30. So those are the types of problems you're going to see on tonight's homework. Good luck.